Dr. Jones is a physics professor emeritus with 20 years experience. He's the co-founder of Scholars for 9/11 Truth and Justice, as well as a co-editor of the Journal of 9/11 Studies. For most of his career, he was known mainly for his work on fusion. In the fall of 2006, amid controversies surrounding his work on the collapse of the trade centers, he was relieved of his teaching duties and placed on paid leave from Brigham Young University. In 2006, he retired from teaching, and he misses teaching and is glad to be here today doing that again. He comes from Utah, where he has a lovely wife. At this point, he now has started the S&J Scientific Company, which is in Utah. So he's published in over 50 peer-reviewed journals, including Scientific American, Nature, which is the premier science journal in which he's been published 3 times, and the Physical Review Letters. So let's welcome Dr. Stephen Jones.
Thanks, Jenna, so much. Thank you. Thank you. I appreciate that. Thank you very much. It's a great honor to be here in Sydney, Australia, and a great pleasure to be teaching again. I really do miss teaching. Today, I will approach this as a lecture to a worldwide university. Since I no longer have an active university position, I realize that I miss teaching very much, and so I realize also that as this is videotaped, that this will go out to a worldwide university. So I welcome you as students around the world, and I will try to treat this somewhat as a lecture that I would give, perhaps a last lecture, in a series of other lectures. And today we'll be talking about World Trade Center destruction, the destruction on 9/11 that occurred at the World Trade Center, as everyone in the world, I think, is aware of that. We'll look at some behind-the-scenes events that not so many are aware of, that people tend to shy away from, but we'll confront this as good, inquisitive, critical thinking students, and we will seize the bull by the horns and see what really happened on 9/11. That's our goal. So I will first talk now about the World Trade Center dust. How can we tell if it's dangerous? We do experiments, of course, and those experiments were done early on. And then some of these other topics you'll see as we address these. Let's look at this dust. We all saw the enormous dust clouds generated as the World Trade Center buildings were brought down one way or the other. The dust was tested by scientists immediately to determine the degree of danger. Greg Swayze of the United States Geological Survey wrote, "Tests revealed the dust to be extremely alkaline, a pH of 12.1. Some of it was as caustic as liquid drain cleaner." Now, you wouldn't want to drink liquid drain cleaner, to say the least. But you can imagine this dust, as it hits the moisture in your lungs and nose, it becomes this extremely caustic fluid. It was obvious that precautions had to be taken to protect the workers and people. So, you see, this dust was deemed by scientists immediately through experiments to be extremely dangerous. It also contained asbestos and some other nasty stuff like mercury from all the fluorescent bulbs that shattered and contributed to the dust, you see. These results were sent to the Environmental Protection Agency, EPA, in the United States. However, the EPA issued 5 news releases within 10 days of the attacks, 9/11, 4 more by the end of 2001. All of these reassured the public about air quality. But nevertheless, even though they were reassured, respiratory ailments began to surface in hundreds, because you cannot deny the facts. This dust is extremely hazardous, and it was hurting people. Now, why would the EPA issue reassurances about the dust when it was, in fact, extremely dangerous? You might ask yourself that question. A BBC News report noted that the number of people with medical problems, primarily from the dust, has risen to at least 15,000. It is expected that more people will die prematurely than were killed on 9/11. So this is a very serious concern, this terrible dust. Now here's what happened. As you see down towards the middle of the slide, a report was issued by EPA Inspector General Nikki Tinsley. She studied what happened, and this came out in the summer of 2003. And here's what happened, reading now at the top. At the White House's direction, this is the Bush-Cheney administration, the EPA gave New Yorkers misleading assurances that there was no health risk from the debris-laden air after the World Trade Center collapse. According to this internal inquiry, she's doing her job. The White House convinced EPA to add reassuring statements and delete cautionary ones. Now, how would you feel reading this and you breathed this dust? You dutifully went back to work. As you remember, the Bush-Cheney administration encouraged people to do, particularly in the financial districts. Let's get back to work. And yet this dust was, in fact, exceedingly dangerous. Read a little more about this. This is from the Downtown Express newspaper as this report came out. This is from Jane in New York City, New York. It was much more important to open up Wall Street than it was to worry about our health, said former city councilperson Catherine Freed. We've known it was a cover-up since the beginning, Jane said. And so you have people aware finally of the government having lied to them. I mention this in part to help you understand that here is a clear example, irrefutable, I believe, of the government of the United States lying to its own people. Now, you might ask yourself, is it serious? Well, it's serious to the 15,000 who are impaired because of breathing this dust when they were told it was safe, and it was not. Not at all. Now, as we look at this toxic dust incident, what does it tell us about the values? Truth. The scientists were outspoken, several of them, including this Greg Swayze, warning people about the true dangers of the dust despite what the government was saying. Caring for others was certainly absent on the part of the government, and the long-term effects, which that's one thing. It took a long time for these ailments to, well, for most people, it took a long time for the ailments to show up. Actually, for some, it was right away. By the way, these characteristics, these values, truth, caring for others, and considering long-term effects, I find in what's called the 9/11 truth community as we seek the truth and we care for others and try to share. And think about the long-term effects of 9/11 and of ignoring 9/11. Next question, why were there no air defenses on 9/11? Associated Press report noted the scrambling of fighter aircraft at the first sign of trouble, such as a hijacking or even a commercial plane going significantly off course, is a routine phenomenon. In the year before 9/11, fighters were scrambled 67 times. This is not an unusual event. A Boston Globe, a NORAD spokesman says its fighters routinely intercept aircraft. When planes are intercepted, they typically are handled with a graduated response. They don't just go up and shoot down a commercial plane because it's off course or even hijacked. They try to get the plane to land safely, okay? This is not, there's this supposition that if you go up, these fighters are just going to shoot the plane. No. But these let's look at them. Let me come back here. These flights, the American and United flights that were off course, these are the three planes that actually collided with buildings on 9/11. You notice I've assembled the data here so that you can see when the planes were taken over. That means they're off course. And for instance, American Airlines 11 was taken over at 8:20. It crashed at 8:46. You see, so there's 26 minutes. Actually, that's plenty of time to respond. United Airlines 175, 842 was taken over. It crashed at 9:03. The main one I want to call your attention to here is American Airlines 77, taken over and off course at 8:46. Did not hit the Pentagon until 9:38. That's over 50 minutes where it's off course, and there were no air defenses to protect the lives of the people on the plane as well as in the Pentagon. World Trade Center 7 on the afternoon of 9/11 of '01, and it collapsed then 7 hours after the towers had fallen. In the photograph in the lower right, you see Building 7, viewed from the rubble of the World Trade Center area and looking across. This would be the side that would be hit by debris from the World Trade Center. It's a little, there's so much smoke in the area, it's hard to see much detail, but I don't see any huge gap. Of course, the Building 7 stood for 7 hours after the collapse of the towers. So obviously it was not fatally damaged, it seems. All right, now, the acceleration of the building, Building 7, as it came down. You can see from photographs, this from the, actually from the video, frames that at 1 second interval, you can see that the motion of the roof line, okay, it drops a little here and drops here. I don't care when you start, students, for this. We're talking about acceleration now, okay? So it's the change, the delta in the motion that counts. It drops a little, and then it drops more, then it drops more, and more. That is accelerated motion, not constant motion. If it's constant, it would drop the same amount, the same distance each second, right? You can see, I hope from these data, that the building is accelerating in its fall. Now, listen to this, please.
This next question comes from Dr. Stephen Jones. NIST discusses the fall time for WTC-7 on page 40 of the summary report, where it stated, assuming that the descent speed was approximately constant. However, observations by others of the descent speed show that the building is accelerating rather than being at constant speed. So the question is, why did NIST assume that the descent speed was approximately constant?
In the summer of 2008, when NIST came out with their preliminary report on Building 7, we were allowed to ask them questions by email, not in person. We've tried to sit down with them in person. They have declined to meet with me and other scientists in person. But they had this press conference, as you see in this room, where they were fielding questions sent to them by email. So I pointed out in their report, you see it right here in yellow, assuming that the descent speed was approximately constant. This is for World Trade Center 7. Well, you know, this is a very obvious error, okay? It's a junior high school student type of error to assume that the descent is constant when anyone can look at the data as they're supposed to do, they're charged to do by Congress. You can see that it's accelerating in its descent. And so I sent an email in, and I actually asked 3 questions. This was one of them. And in response to this, by the way, one of the others was, how about this explosive material, this red chips I'll talk about soon. Did you look for explosive residues in the dust? And they basically said, we're not going to look for explosive residues, period. So it's very sad. That's, again, unscientific not to even look. But here's what they came up with in response to my question, and David Chandler asked them a very similar question. We asked them, without talking to each other first, we asked NIST to explain why they would use, why they didn't consider the actual acceleration of World Trade Center 7. So here, and now this is looking at the roof line, and you can see this is now in the final NIST report, where they do agree and they admit that this, looking at the velocity of the roof line as a function of time over 2.25 seconds, it's a straight line, very close to that. It fits very well to a straight line. And then they actually do the determination of the slope. A physics student could easily take these data, look at the delta v sub y over delta t, and you'll get the acceleration. It's linear on this plot, and you get the acceleration. Here's what NIST wrote in their final report. The slope of the velocity curve is approximately constant between 1.75 and 4 seconds. A good straight line fit to the points in this range allowed estimation of the constant downward acceleration during this time interval. This acceleration, here's the punchline, was 32.2 feet per second squared, 9.81 meters per second squared, equivalent to the acceleration of gravity g. Folks, that's the same as if I took a steel ball and dropped it. Nothing in the way. Okay? That's free fall, and they admit that. This free fall drop continued for approximately 8 stories, 32 meters, 105 feet. That means that this roof was falling for some 32 meters with nothing slowing it down. I'm going to borrow from Frank Legge's paper a minute, this nice little illustration. This is for one of the towers, but the same thing applies at Building 7. If you have a block of floors, including the roof, falling onto columns and concrete, hundreds of thousands of tons of mass, and then this one falling just freely, right? Nothing, somehow we've moved stuff out of the way. We'll talk about that, but you have to, it's not just the support columns, it's also the mass. The mass alone will slow down so that you cannot accelerate at g, which is the acceleration due to gravity. You understand? Students, rest? Okay. So let me ask you, which of these two roofs, the one on the left or the one on the right, will fall more slowly? This is not a trick question.
The one on the left.
The one on the left will fall more slowly. And why is that? Okay, I hear several answers, and I'll help you. Inertia, well, yes, conservation. Something in the way is the easiest way to put it. It boils down to conservation momentum. When a moving mass hits another mass, it slows down. It's conservation of momentum. And the third law will get you the same answer, Newton's third law. There's an upward force applied to something that hits this object with a downward force. There's also an upward force. So obviously, to get free fall, somehow you must have moved hundreds of thousands of tons of material out of the way. Now, fires will burn up paper and desks and so on. Will they burn up concrete? No, not just unlikely. No, the answer is easy. How about steel? Will they vaporize steel? No. So how do you, let's think just for a minute, how do we move thousands of tons of concrete and steel out of the way, or at least get it falling at the same time so that the roof is unimpeded, you see? How do we do that? Explosive. No, it's not magic. No. It's explosives, right? That's one way to do it. And indeed, if you look at controlled demolition where explosives are used, so you cut columns below the roof line, the roof indeed falls at close to acceleration due to gravity, g, just as World Trade Center 7. How do you get the mass out of the way? Now, NIST does not answer. We basically pushed them to include this plot because we challenged them, David Chandler and I, and they did it to their credit, but then you'd say, well, they would have to explain it, right? Or explain the collapse of the buildings, but they didn't. They just put a little statement in there. They said that this result is consistent with the results, that's where I start quoting, consistent with the results of the global collapse analysis, that means their computer model, discussed in chapter 12. That's it. It's a sham. I hope you understand that as a scientist, I'm offended by this type of covering things up. I mean, we challenged them. They admitted free fall for Building 7. Free fall for some 32 meters, over 100 feet. And then you're waiting for them to say, well, fires won't do this. But instead, they just say, oh, it's consistent with our computer model, which we won't let you have, which you can't test. You can't see if it's consistent or not. You just have to trust us. You see? Like when we say the dust is safe, please just trust us. No harm will come. Please. You know, as a scientist, I just am appalled. So here's again, we contrast students, the scientific method with the political method. In the scientific method, we gather facts, and we then draw our conclusions from the facts, as on the left. In the political method, we start with a conclusion, and then we find what facts will support that conclusion, and we ignore all others, or we simply say, oh, it's consistent with our theory that fire can explain it, and Al-Qaeda is solely responsible. By the way, you know that no plane hit Building 7, don't you? Al-Qaeda did not even hit Building 7, and they ruled out, NIST ruled out as they checked, that the debris from the falling towers did not cause a fatal incident at Building 7 either. So they're stuck with fire, which indeed was caused by the towers, they say. But gosh, the way it fell down is not consistent, no, with fire. This is free fall. Plus the fact that in Building 7, Professor Barnett et al. At Worcester Polytechnic Institute noted that the steel was severely eroded, high temperature corrosion and sulfidation, which again Richard Gage talked about that. Do office material fires do this to steel beams? The answer is no. I mean, please do the experiment. Show me wrong. I beg of you. Show me how you can get a steel beam to look like this. Swiss cheese in appearance, burning paper and desk and so on. Kerosene would be the jet fuel in the towers. There's also steel like this found in the rubble of the towers and studied by these scientists at WPI. Now, did NIST follow up on these data? It's in the FEMA report and was published also in a peer-reviewed journal. The answer is no. NIST did not even look at any steel from World Trade Center 7. Not even these pieces that were collected. Again, they ignored the data. They asked us to trust their computer model, that somehow the free fall for over 2 seconds is innocuous, if I can use the term. Don't worry about it. Well, excuse me. There's something very strange going on. I am not just going to believe you that this is okay. It's just appalling. But hopefully they will someday say, well, like they admitted, we can't explain the total collapse of the towers. Well, perhaps they'll admit that with regard to Building 7 as well. But to ignore published data is, again, an offense in science. Okay, students, you're better than that. Let's see. I might say that this effect of holes in steel I was able to achieve quite easily using thermate, which is sulfur added to ordinary thermite. Thermite you can buy on eBay. Sulfur is not hard to come by. You mix them together and you ignite it. I use a sparkler to ignite this typically. And you see the effect is, and I've looked at this with a scanning electron microscope as well. You see the sulfur penetrating the steel very quickly, and it forms a eutectic and it melts its way through. This is not even super thermite, which we'll talk about later. Just ordinary thermite with sulfur added. The steel is cut through, melted, and it has this Swiss cheese appearance. We're able to duplicate that. The WPI scientists also found sulfur in the steel in these samples. Where does it come from? You see, well, we have an experiment that can replicate. That's not a proof yet. To prove it, we would need to get a sample of this steel. We requested, as my colleague at BYU, Dr. Ferrer, talked to Professor Barnett at WPI and requested a sample of the steel, a scientific courtesy. He was refused. They will not. Now, somebody must have power to get these guys to let us look at their computer model, right? And we'll plug in the actual heat transport value for steel and realistic values for fire and so on. And also to get a sample of this steel. That's what we want. We're looking for data. We're not just trying to, be contentious. We want the facts. We have a right, I think, to ask these questions. In the past, asking questions has been commended, not condemned. Now about the towers. We'll go through this kind of quickly. Richard Gage has a great article on that. I want to show you, you see here in the upper right, you have a stove burning wood. I have a wood burning stove. And sometimes I'll put paper in there. So it's much like an office fire, I suppose. office materials, typical in office, wood, paper. You could even put kerosene in there. I have a kerosene burning stove. It's also made out of iron or steel. You know, I don't expect that stove to deform and melt or collapse. It's just not going to do it. I've done the experiment many times. My kerosene stove also is quite happy to burn kerosene. You know, a jet fuel would be fine. It's a type of kerosene. I don't see a problem. Furthermore, you look at the connections on these columns. They're connected together. Well, you can see it in the picture on the right. That means that if you have a bonfire under one, go ahead, pile up all the desks and chairs and paper under one of those columns. And you start that fire off, and it lasts maybe a half hour, something. But that heat is wicked away. Again, it's this heat transport, you see. And so you have to take that into account. Except in a computer model, of course. You can get away with murder, actually, if you think about it. But okay, back to the official model now presented by Besant in a published paper. How to get a complete tower collapse. Their argument in this paper is that where the planes went in and there are fires, then somehow there's this weakness, rather simultaneous, and this upper block of floors acts as a tamper to push down. So it stays fairly intact as a tamper. Makes some sense, right? But wait a minute. How about Newton's third law, which says that if the upper block exerts a force on the lower block of floors, the lower block exerts an equal force, students, on the upper block. Equal. That arrow is not shown, is not considered in this paper. It's there. You cannot overcome the laws of physics. Now, this is, again, a freshman error in physics, Newtonian physics, which I taught for over 21 years, to ignore the third law reaction force. But let's look at the data. Maybe somehow this upper block, as it moves, I don't know, exerts. Let's see what happens to the upper block from the data. This from the North Tower. And on the right, you see in slow motion, the upper block. Is it just wiping out the lower block? You can see the area where they meet. No, the upper block itself is being disintegrated. Did you see that? Let's look at it again, please. You can see the antenna poking up there. The antenna went through the whole ride of this thing. But you see, there's a force equal and opposite, up and down, and the upper block, which, by the way, has thinner columns. That's the way it was built. The columns get, the core columns get smaller, thinner as you go up. Furthermore, the fire would have weakened the upper columns, and indeed that's what you see. It's the upper columns that are destroyed. So then what is left, where's this block, this tamper that's supposed to wipe out the lower floors? Sorry, it ain't there, you know. I mean, look at the data. It just bothers me that they have this nice model on the left, but it's inconsistent with observation. It's also inconsistent with Newton's laws. Here's another photo showing later as one of the towers has collapsed. You can see the zone of destruction. It's quite clear, isn't it? You can see where right through here. But where's the tamper? Where's this block of floors? Well, indeed, there's smoke coming up there. It's gone. On both towers, you see this effect. That upper block of floors is gone by the time you get halfway down of the buildings, approximately. It's gone. There is no tamper. And it doesn't wait till you get to the ground for the upper block to be destroyed. It's already destroyed. It isn't there. It's just amazing to me that they missed that. So the official story is full of holes, just like the steel found. You see, it's just full of holes. By the way, the towers also came down at near free fall speeds. No stacked up floors. Here's an actual photograph then following the collapse. Where are the stacked up floors? If there's some pancaking going on, like the Popular Mechanics article said, they're not there. On the right, we have pancaking that can occur, but it didn't occur at the World Trade Center. There is no stacking of floors. Furthermore, the core columns are gone. Those core columns provided a lot of the support in these towers, and they are gone. That suggests again to me use of explosives. Now, let's see, as I started writing about this, and here's one of these papers that I asked you to read as homework, I received an email from a fellow who identified himself as a contractor with Homeland Security contacts. As soon as this article was out on the internet, he wrote to me. I'm going to quote from his email. "The publication of this article can be stopped, and I have the contacts to make this happen. You need to give this very serious consideration. This is an issue that is more important than any individual career." I think he was talking about my career. "As painful as it may seem now, perhaps it may be less painful than could occur after publication." That almost sounds like a threat. I don't know. "I have learned to appreciate the value of silence, even in the case of superior data and information." He could not refute my arguments, and so he said, "Shut up anyway." "I have learned to appreciate the value of silence." Now, this paper was formally published in a book by Professor Scott and Professor Griffin in August of, so there's several things happening, but anyway, August of 2006. In September 6th, I was put on administrative leave. I think this was probably part of it. And that was pretty much the end of my teaching career. Here I am teaching to a worldwide university, so thank you. Okay, thank you. NIST has found no evidence, this is quoting NIST, NIST has found no evidence of a blast or controlled demolition event. They made that statement, and then we wondered, because we're getting just a little bit skeptical, you see, we're thinking like scientists now. Wait, did they even look for explosives or explosive residues when they make this statement? Turns out they did not. So an investigative reporter, the reference is at the bottom, her name is Jennifer Abel, called up the NIST spokesman, name is Newman. She asked, what about the letter where NIST said it didn't look for evidence of explosives? See, they didn't even look. They admitted that finally in a letter. Newman, who's listed as the spokesperson, right, because there was no evidence of that, huh? Shh, go away. Abel, Jennifer, but how can you know there's no evidence if you don't look for it first? Good girl, that's it. Investigative reporting, let's find the answer. Newman, if you're looking for something that isn't there, you're wasting your time. Now, am I missing something here? I mean, this is offensive to my intelligence. How can you know in advance? You see, this could just keep going on circularly forever, but yeah. Okay, more information you can find at the Journal of 9/11 Studies, and here's some of the authors, as well as, of course, in these peer-reviewed established publications. Now, red and gray chips, a lot of fun stuff to talk about, but it's scientifically fun. In terms of what it means to society, well, that's up to us. It's an adventure to be in this with you worldwide addressing these issues. An adventure to me. So in June of 2007, I observed many of these red-gray chips, as you see pictured here in a sample of dust from the World Trade Center. We finally obtained 4 independently collected samples, and the chain of custody is well established with witnesses, in some cases with videotape of the collector explaining how he or she collected the dust. By the way, we know that USGS has dust samples from the World Trade Center. We've requested dust, and they say they just don't have enough. All 4 samples, this is a check we did, had the same active thermitic material, this red material, and it has been seen independently now by Mark Basile working in Massachusetts. Here's an electron microscope. Higher magnification using an electron microscope. We go in, you see the red layer on top. This is in the paper, so I'm going to go through this fast because you can read it in the active thermitic material paper. This is also from the paper. We see aluminum, oxygen, silicon, iron, carbon, prominent, no zinc. Primer paint, we check this, the primer paint. This is a knee-jerk reaction of the debunkers. Oh, it's just primer paint from the, painted onto the steel. It's just primer paint. Primer paint has lots of zinc. But we've gone a step further now. This is a new result that I want to show you. And that is there is actually a monument for 9/11 that contains actual steel from the World Trade Center 7. The fellow who put the monument together, welded it, he went out, he's now a 9/11 truther, and he went out and scraped off some of the primer paint from this World Trade Center 7 steel. Now we're going to compare with this red material. And the result, drum roll, is that they, thank you, on the left is the red material, the thermitic material. On the right is the primer paint. So are they the same or not? Well, in the primer paint, you see a lot of elements. Iron is Fe, CO is cobalt, chromium, calcium, potassium, sulfur, silicon, aluminum, magnesium, and zinc prominently. Here's zinc over here too. It's going off the page. See a little better there. With this method, you excite the atoms and they release X-rays, and then you can identify the elements. The differences, I hope you can see, are distinct. The right is the primer paint, and the upper one is, 2 plots upper, is the red material, you see? So the red material shows no zinc. Right away you see that. That was the critical factor. We knew there would be zinc in the primer paint. There is no zinc in the red material, and indeed we do see zinc prominently in the primer paint. Magnesium is also seen along with, chromium. Prominent chromium peak, as you expect from the composition of the primer paint. They're not the same. We also had a reaction from a debunker who said it's kaolinite. If you'd done a little checking, the USGS data shows this kaolinite, sure enough, it has aluminum, oxygen, and silicon, but no iron. And so it's just not the same. Furthermore, the behavior, here's an independent sample. The behavior when we ignite this stuff, comparing and when we treat it with a paint solvent, these are entirely different behaviors between the primer paint and the red chips. So here's, for example, soaking one of these red chips. It swells up, but it's still hard. When I soaked the primer paint in MEK, which is a solvent, methyl ethyl ketone, the paint became very limp. You can do this experiment. See, that's the beauty of science. It doesn't matter whether you're a 9/11 truther, so to speak, like myself, I seek the truth, or if you're a debunker, or why is it the debunkers don't do experiments? This is what I like to know. You can do the experiment. It doesn't matter what your biases are. That's science, right? And when you do the experiment, then you publish. And somebody who wants to challenge you, he might be an atheist from, I don't know. It doesn't matter. You do the experiment, you get the same result. You see, that's the beauty of science. And then you find out facts that way. It's not like, oh, there's a big debate about this because who says this and who says... No, it doesn't matter. It's experiments and peer-reviewed papers, you see? That's how we proceed in science to get at the truth. Here's an X-ray diffraction pattern of a red chip. We're just starting into these studies now in earnest. And we hope to learn more with this independent technique. I want to point something out. As we look at high magnification, this is 50,000 power amplification in the electron microscope. We see, okay, let me point out to you these in the middle, if I can get there, these platelets, that's where the aluminum is held. These dots, you see the dots here? These faceted dots, that's where the iron is held. And then this stuff out here that looks kind of gray, that's the organic. There's a lot of organic material. Now, the uniformity of these plate-like structures and the narrowness of them, these are remarkable. I have no idea how to make these things. And by the way, the aluminum we can separate from the silicon using MEK, so it's a very interesting material. The iron oxide, these ultrafine faceted grains, plus the organic matrix. This is not building stuff that just falls down and makes this wonderful nanothermite. I've heard that argument. I think, have you read the paper? Do you know how complex this is? You see, this takes some considerable knowledge, chemistry. In fact, we have a couple of chemists on our scientific team, and we have not been able to make this stuff. We don't even know how to do these. See, aluminum oxidizes very quickly. Somehow the silicon layer has passivated the aluminum. That means it makes it insensitive to the oxygen in the air, so that in this matrix it is preserved so that, 8 years after the event, this stuff still blows up when we cause it to react. You see, we've got the flowing material, and we've tried to stabilize the image for you so you can see this molten orange glowing material. There goes off the white wisp, which is, we think, then aluminum oxide. There's an important thing to understand here, and that is thermite, ordinary thermite, which you can buy on eBay, is incendiary. It burns, well, you say slowly, even though it's over in a flash. It's not explosive. It melts through stuff like steel. Ultra-fine grain nanothermite, now it's called, is an explosive, or it can be made. It can be tailored, actually, and explosive. This, below you see a photo, lower right, from Lawrence Livermore Laboratory, which BBC asked if they could show this photo. It's a published paper. Lawrence Livermore Labs refused to allow BBC to show this publicly. Well, here I am. It's shown publicly. Please sue me. I need to get the word out, if that'll help. But, it's so funny. This remarkable structure on the left is from, again, Livermore Labs, showing, again, this intimate mixing of iron oxide and aluminum in a sol gel framework. It's remarkable stuff, this nanothermite. And here are the analyses before and after ignition. Top is before. You see the composition. After, you see the aluminum is almost all gone. It has gone off into the air, aluminum oxide, as this reacts. What you're left with is iron, reduced iron. Now, see, before the oxygen peak is very large compared to the iron peak. Afterwards, the oxygen peak is small, and we were able to determine that the iron has been reduced. That is, the oxygen has transferred from the iron to the aluminum. Don't worry, that won't be on the test. But you still have to read the papers, okay? And where does the aluminum come from in these spheres in the dust, the bottom one you see? That's an unusual mix, iron, silicon, aluminum in a sphere. Some of them, the aluminum goes off more, but some of them, it's trapped or whatever, and the aluminum's there. What an unusual mix. Where does that come from, if not from this thermite or nanothermite? Quoting from Livermore scientists, they published a fair amount. So you see, let's see what they say about this. By introducing a fuel metal, a quick pop quiz. Oh, the answer's there. Too bad. I was going to quiz you. What is the fuel, such as aluminum, into the metal oxide, silicon oxide matrix? Okay, what's the metal oxide that we observed? Iron oxide, great, in these red chips, right? The silicon oxide is a matrix in which they're holding this fuel plus oxidizer. Energetic materials based on the thermite reactions can be fabricated. Now, organic additives, what's all this carbon doing in there? Can cause the generation of gas. That's what it's for. Upon ignition of the material, so you expect gas to be generated, resulting in a composite material that can perform pressure volume work. In other words, as it explodes, you get this hot gas. That's the trick used with C4 in a shape charge to produce this hot gas and molten metal that squirts through and cuts very quickly through steel. That's the trick. See, when I first saw this stuff, I could not understand what it was, because there's silicon, which is not needed, I thought, in thermite, and carbon. What's that for? Well, now I know what the silicon's part of the structure in the sol gel method of formation, and the carbon, the organic, you see, which has carbon, is used to generate gas. It all makes sense now. Now we have to do a comparison as good scientists. These scientists previously have published what happens when nanothermite is ignited. That's the red curve. When we ignite an actual red-gray chip from the World Trade Center dust, we get the blue curve. This is done in a differential scanning calorimeter. Yes, that will be on the quiz. And you see the narrowness of the peak tells you how rapidly, it gives you a good indication of how rapidly the reaction occurs. The height of the peak, or the integrated area, rather, tells you the amount of energy that's released in the reaction. What we found is that, and also the temperature at which the material ignites tells you quite a lot about its nature as well. Now, let me just show you one thing. I'll come back. There's a lot of data here. You probably have to read the paper to really understand it. This is in a paper published in 2004. And again, these are the boys at Livermore Lab. And on the right, we have nanothermite, a very narrow peak at about, I'm saying around 550 centigrade it goes off. The broader peak with ordinary thermite on the left goes off somewhere around 900, 1,000 centigrade, higher temperature. So by going to finer material in the nanothermite, the temperature goes down for ignition and the peak gets narrower. That's what we see with this amazing red material found in the World Trade Center dust. The blue curve, it's very narrow. It goes off rapidly. My friend Dr. Farrer says, yes, it blows up. You know, he's done a number of these tests. And then the temperature is actually lower than what the Livermore boys did when they did their nanothermite. So that's, it's a very interesting material. Read the paper for more detail on that. Here we go. First time this has ever been shown publicly. This is a red chip at very slow motion going off, very slow motion. These data were acquired by Mark Basile in Massachusetts using, I don't know exactly how he did it, but a camera through a microscope and then he hooked the frames together to produce this moving picture. So the red chip, you see the red there, gray on top, it swells, it turns black, gives off a gas, and then it flashes, boom. Now if this were confined, that gas might react instead of just going off. That's an experiment I'd like to see, but one more time. And you'll see the red-gray chip very clearly. It's being heated on a stainless steel strip, gas given off, flash goes through very rapidly. Again, this is at ultra-slow motion. In the paper in which we discuss these red-gray chips, you'll find a reference to this AMTIAC quarterly journal. This is kind of exciting. Okay, figure 1 talks about the applications for this. It's called nanocomposite. Nanothermite is an example of it. These guys, Livermore, thermobaric warheads. And then down at the bottom, a shaped charge. Can you see that? Let's see if I can use the pointer. So you see this is hollow here. Here's the material like C4, conventional explosive, in a shape such that when it explodes, you get a blast of gas, and then typically there's a copper liner also there, so that you get molten metal blasting out to cut through steel. That's how shaped charges work. See the shape there? It's kind of a cone, or if you linearize that, it becomes this wedge that forms the shaped charge to cut through steel. That's how buildings are demolished. Now notice what they're saying about the fuse right here on the end. See, they're pointing to that. The fuse or initiator, they're recommending a nanocomposite or nano intermetallic, of which a prime example is discussed in this article, which is a Department of Defense article, U.S., is nanothermite, nanocomposite as the fuse or initiator. In my opinion, this is the more likely context in which nanothermite was used in the World Trade Center buildings. Obviously, to find out for sure, we would have to either find unignited, well, we have the unignited nanothermite, but I mean unignited shape charge, which is unlikely. All that's been hauled off and melted, all that steel. Or find someone who knows, ask the questions, the tough questions, and get them subpoenaed. So here is the picture I'm suggesting now. This is my best thought of how nanothermite was used in the World Trade Center. It was used in these shape charges, and the top center you see a shape charge, conventional, being applied to a steel beam. Isn't that amazing, this line? It must be about a centimeter, a couple centimeters wide, and then across the beam, electrically set off, and that cuts through that huge steel beam. See? It's remarkable. Just remarkable. On the left, lower left, you see an example from the World Trade Center, which is quite interesting to me. But of course, that steel is no doubt melted. That's what they did with over 99.7% of the World Trade Center steel. It was melted. It was sent to Asia, melted, destroying the evidence. We have the dust. We can learn a lot from the dust. But I'm suggesting that the nanothermite would appear then as a fuse or initiator. Now, why would you use nanothermite? Here, this is from Los Alamos, another national laboratory in the United States. I've worked at the lab as a postdoc for years. What they are talking about here is super thermite matches. So you have the nanothermite, also called super thermite, in these silvery globules with two wires, you see. You simply send a current through the nanothermite and it sets it off. Applications, according to Los Alamos, include triggering explosives for demolition. I'm not making this up, students. This is straight out of the publication, 2003, which you can find from Los Alamos National Lab. Why would you want to do that? First of all, you can touch this off electrically, this stuff, this nanothermite. Secondly, the superthermite matches are safer to use because they resist friction, impact, and heat, thereby minimizing accidental ignition. That's why you would want to use this. If you're worried about things going off prematurely, here's your solution. Plane hits building. We don't want too much to go off. Oh, super thermite matches. So then I got thinking, you see, why don't I try putting a voltage across this, one of these red chips from the building? I wish I had that on video, but I was acting alone. I've lost my position at the university, but I was acting alone with a car battery and these two sharp probes and a 12-volt battery, you see. And I touched one of the, I'll get it on video here, and I've recommended it to Mark Basil. He's set up better in Massachusetts. But he was skeptical at first as I talked to him, but he's convinced now that there's this explosive pyrotechnic material in the World Trade Center dust. So you touch the two probes, apply the 12 volts. I was holding it by hand, the two probes on the red chip, and it just went and of course I backed up very quickly, and I decided in the future, this is just a little chip about, less than a millimeter square, it's tiny, and I will have to have some remote way to do this. I figured out a way to do it. Another thing, by the way, I sent chips by U.S. mail to a post office box in the Midwest to a scientist. When it got there, and this was on an inner envelope and an outer envelope in a plastic vial that was closed tight. Two little chips. When it got there, the scientist opened his post office box, and as he checked, there was a slit in the outer envelope. There was a slit in the inner envelope that lined up. The vial, as he removed it, the chips were absent. U.S. mail. I feel like we have, Big Brother watching a little bit. Now, I sent, in that case, I told him, okay, the chips are coming. By email, I was communicating. More recently, I've sent chips quietly to Europe and an independent lab in the United States, and they did both arrive. I just didn't tell them I was sending them. And then they arrived, and they say, well, what's this? And, of course, then I could tell them. Here's again from Los Alamos about these super thermite electric matches, showing them going off. By the way, a colleague, I just got to tell you, a colleague asked Los Alamos, can you give us a sample of this super thermite match? You have photos of it. You have papers on it. What I wanted to do is take one apart and look inside and compare it with the World Trade Center red material, you see. Los Alamos, not only did they decline to send it to us, they said, well, we really don't have any of these. So I don't know. And so I see photos, and it looks like they exist. Maybe they were just faked. I don't know. But how could they set one off without having one? This is, I'm getting to be real skeptical. I'm sorry. We'll carry on. Oh, to make this stuff, this is just to get at the aluminum. The nanoscale aluminum requires sophisticated equipment. This is not caused by a building just falling down and magically aluminum is in platelets with silicon passivated and the iron oxide in uniform granules embedded, uniformly mixed, and embedded in an organic matrix. No, where does all the organic come from, by the way, if you have a building falling down? No, it's just crazy, that idea. I just am, again, appalled. There's some scientist who said that, and do you understand what you're saying? I mean, look at the complexity of making this stuff. So where could it be made in 2001? That's a key question. It turns out there are not many labs that have the capability to make this nanothermite, especially back in 2001. Conclusion, who made the stuff? Why has NIST refused to look for explosive residues in the World Trade Center dust? Also, USGS would not answer my questions about that. Okay, here's something I want to emphasize, students. We can learn a lot from physics and experiments, but how they were used, exactly who did this and how they were used, I keep getting that question. You must understand that observing this red gray material doesn't tell me. There's no fingerprint on this little stuff. We need subpoena power. We need an investigation, perhaps, I think, at an international level. Some government, this was suggested by Bray Antcliffe, did I pronounce it more or less right? And his colleague, both of them lawyers, I hope I'm getting that more or less straight, Bray, that this would be something where, okay, a nation such as Australia, Japan, that lost citizens in the 9/11 event could ask questions of the U.S. government, request, demand samples of the steel, of the dust from official sources, right? USGS, we want that dust to look at for ourselves. We want some of that steel that WPI has. We want the computer model that NIST did. We will have our own scientist test. We want to know what killed our citizens on 9/11. Thank you very much. Appreciate it. Thank you very much.